Article 402.5 addresses fixture wires, but only within the confines of the fixture itself. It doesn't dictate the ampacity requirements for conductors supplying power to the fixture. Article 240.5 B2 allows for increasing conductor ampacity to 125% for branch circuits with continuous loads. However, this exception is not applicable to conductors feeding lighting fixtures. The inspector's decision to fail the inspection is rooted in the National Electrical Code, specifically Article 210.19a, which concerns feeder overcurrent protection. This article mandates that an overcurrent protective device be installed in each ungrounded conductor at the point where the conductor receives its supply. Furthermore, the protective device must possess a sufficient ampere rating to handle the maximum load current of the conductors it protects. Inverse time circuit breakers or time delay fuses must be used. Article 210.20 deals with branch circuit overcurrent protection. It stipulates that branch circuits must be safeguarded by overcurrent protective devices rated in accordance with the circuit's maximum load current. Crucially, the maximum load current cannot exceed 80% of the branch circuit protective device's rated current. Understanding these code sections is crucial for safe and compliant electrical installations. Let's delve deeper into these articles and how they apply to the specific scenario of feeding lighting fixtures. Article 210.19 essentially means that the feeder conductors must be adequately protected against overcurrent. The overcurrent protection device, such as a circuit breaker or fuse, must be sized appropriately to allow the conductors to carry their intended load without exceeding their ampacity. The key here is to ensure the conductors are not overloaded. If the conductors are too small for the load, they will overheat, potentially leading to insulation damage, fire hazards, and equipment failure. Article 210.20 focuses on branch circuits and imposes a limitation on the maximum load current. The 80% rule is a safety margin that prevents the circuit breaker from tripping unnecessarily due to normal load fluctuations. It also helps to extend the lifespan of the circuit breaker by reducing thermal stress. This 80% rule is particularly important for continuous loads, which are defined as loads that operate for 3 hours or more. In the case of lighting fixtures, which often operate for extended periods, the 80% rule applies. Therefore, the branch circuit conductors and overcurrent protection must be sized accordingly to account for this limitation. In the given scenario, the inspector correctly identified that the conductors feeding the fixtures did not have sufficient ampacity to handle the load. While fixture wires might have been compliant within the fixture itself according to Article 402.5, the branch circuit conductors supplying power to the fixtures needed to be sized appropriately to meet the requirements of Articles 210.19 and 210.20a. To rectify this situation, the solution is to increase the size of the branch circuit conductors to meet the ampacity requirements of the load. This might involve replacing the existing conductors with larger gauge conductors or running additional conductors in parallel to increase the overall ampacity. It's important to consult the National Electrical Code and relevant tables to determine the appropriate conductor size based on the load current, ambient temperature, and other factors. The National Electrical Code provides tables that specify the ampacity of conductors based on their size, insulation type, and installation conditions. These tables are essential for ensuring that the conductors are adequately sized to handle the load. For example, Table 310.15b16 in the 2020 National Electrical Code lists the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius in free air based on ambient air temperature. This table provides guidance on the ampacity of conductors for various conductor sizes and insulation types. It's crucial to select the appropriate conductor size based on the specific conditions of the installation. Furthermore, it's important to consider deterring factors that might apply. Deterring factors are used to reduce the ampacity of conductors when they are installed in certain conditions, such as when multiple conductors are bundled together in a conduit or when the ambient temperature is higher than the values specified in the ampacity tables. Deterring factors are outlined in Article 310.15c of the National Electrical Code. These directing factors are essential for ensuring that the conductors are not overloaded and that they can safely carry the intended load. Failing to consider directing factors can lead to conductor overheating, installation damage, and potentially fire hazards. Therefore, it's important to carefully review the installation conditions and apply any necessary directing factors when determining the appropriate conductor size. In addition to conductor ampacity, it's also crucial to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction and reduce its performance. The National Electrical Code recommends limiting the voltage drop in branch circuits to 3% and the total voltage drop to the farthest outlet to 5%. To minimize voltage drop, it's important to select conductors with a sufficiently large size and to keep the circuit length as short as possible. Voltage drop can be calculated using Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance. The resistance of the conductors can be determined using tables provided in the National Electrical Code. By carefully considering voltage drop and selecting conductors with an appropriate size, it's possible to ensure that the equipment receives the proper voltage and operates efficiently. Therefore, to reiterate, the inspector's decision was correct, and escalating the issue is unnecessary. The focus should be on rectifying the situation by increasing the size of the branch circuit conductors to meet the ampacity requirements of the load and complying with Articles 210.19 and 210.20 of the National Electrical Code. This ensures a safe and compliant electrical installation that protects against overcurrent and voltage drop. It also prevents potential fire hazards and equipment malfunction. Always consult the National Electrical Code and relevant tables for guidance on conductor ampacity, overcurrent protection, and voltage drop. Proper planning and execution are essential for a safe and reliable electrical system. By understanding and adhering to the code requirements, electricians can ensure that their installations meet the highest standards of safety and performance. The importance of understanding conductor ampacity extends beyond simply passing inspections. It's about ensuring the safety and reliability of the entire electrical system. Properly sized conductors prevent overheating, reduce the risk of fire, and minimize voltage drop, all of which contribute to a more efficient and safer electrical installation. Therefore, it's essential for electricians to have a thorough understanding of conductor ampacity and the relevant National Electrical Code articles. This knowledge enables them to make informed decisions about conductor sizing and overcurrent protection, leading to safer and more reliable electrical systems. The National Electrical Code is a comprehensive set of standards that provides guidance on all aspects of electrical installations. It's updated regularly to reflect the latest advancements in technology and safety practices. Electricians must stay up to date with the latest edition of the National Electrical Code to ensure that their installations comply with the current requirements. The National Electrical Code is not a static document. It's constantly evolving to address new challenges and improve safety standards. The electrician should make it a habit to review the National Electrical Code regularly and attend training courses to stay informed about the latest changes. By staying current with the National Electrical Code, electricians can ensure that their installations meet the highest standards of safety and performance. In conclusion, understanding conductor ampacity is crucial for safe and compliant electrical installations. The inspector was correct in failing the inspection due to undersized conductors feeding the lighting fixtures. The solution is to increase the size of the branch circuit conductors to meet the ampacity requirements of the load and comply with Articles 210.19 and 210.20 of the National Electrical Code. This ensures a safe and reliable electrical system that protects against overcurrent, minimizes voltage drop, and prevents potential fire hazards. Always consult the National Electrical Code and relevant tables for guidance on conductor ampacity, overcurrent protection, and voltage drop. Proper planning and execution are essential for a safe and efficient electrical system. Remember to consider directing factors when installing conductors in specific conditions. These factors are crucial for ensuring that conductors can safely carry the intended load without overheating. Voltage drop is another important consideration. Excessive voltage drop can cause equipment to malfunction and reduce its performance. To minimize voltage drop, it's important to select conductors with a sufficiently large size and to keep the circuit length as short as possible. The National Electrical Code provides guidance on limiting voltage drop in branch circuits and feeders. By carefully considering these factors, electricians can ensure that their installations meet the highest standards of safety and performance. Furthermore, it's essential to use appropriate wiring methods and materials for the specific application. The National Electrical Code specifies the types of wiring methods and materials that are permitted for various installations. Using the correct wiring methods and materials is crucial for ensuring the safety and reliability of the electrical system. For example, some wiring methods are suitable for dry locations, while others are suitable for wet locations. It's important to select the wiring method that is appropriate for the environment in which it will be installed. Similarly, some wiring materials are more resistant to heat and chemicals than others. It's important to select the wiring material that is compatible with the specific application. By using appropriate wiring methods and materials, electricians can ensure that the electrical system will function properly and safely for many years to come. Also, grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which allows the overcurrent protective device to trip and energize the circuit. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are crucial for preventing electrical shock hazards. The National Electrical Code provides detailed requirements for grounding and bonding. Electricians must follow these requirements carefully to ensure the safety of the electrical system. Finally, electrical safety is everyone's responsibility. The electrician should always follow safe work practices and use appropriate personal protective equipment. Homeowners and other individuals should also be aware of electrical safety hazards and take precautions to prevent accidents. By working together, we can create a safer environment for everyone.